So the problem apparently is that however many times, that's what we have just established, however many times you repeat the prisoner's dilemma, it does not change how things are, right? Players still stick to their dominant strategies, and that is defection. So some people thought, okay, maybe we should try to model prisoner's dilemma as if it was not so strict, so as if it was not the prisoner's dilemma specifically which was repeating itself, and that in the last round they did not have the same game. So just to give you an example of what that could mean, the prisoner's dilemma is still there. So there is this game, cooperate, defect, same payoffs, 2, 2, minus 1, 3, 3, minus 1, and 2 zeros. Of course, same players, first and second. And they play this game. However, from this game, they proceed into a game which looks like that. So this is actually the game we're talking about. This game is actually the prisoner's dilemma with two prisoners. And imagine that they had to keep silence in the first round, cooperating with each other, not defecting each other, not telling stuff to police. And if they do, then they go to prison. But if they keep silence, if they cooperate with each other, then they avoid going to prison. And there is one particular development. In the second stage, they both observing what had happened in the first stage. And of course, they know what happened there because they know their own behavior and they can see the payoffs, right? So for instance, if one of them was cooperating and sees herself put to prison, then she knows, all right, apparently the other player was defecting on me. So that's how I ended up in prison. So they can infer the behavior of each other because they can observe their own payoffs. And after having observed their own payoffs in the first round, in the second round, they have to decide between these two strategies. They can either join again, or stay out of it, not join again, right? Both of them have the choice. The idea is that if once you get to prison, once you're in prison, well, at least that's what the American pop culture teaches us. You have to join the gang because otherwise your days in prison will be very tough. But in this particular game, joining the gang means that that you can use its resources to punish the other player for defecting on you in the first round. And the payoffs in the second round are as follows. If the players not join the gang, they both get zeros. Nothing changes for them. 0 and 0, right? If you don't join the gang, then, well, you don't get this criminal experience, but you stay out of all of this shady criminal stuff. And actually, that's the best thing, guys. If I may suggest, if I may recommend you something, don't join gangs, all right? However, if they join the gang, then this is what they can do. For instance, if it's the first player who joins and the second who does not, then the first bears some costs of being in a gang. That's -1, right? Because criminal life, thug life is uncool. But then the first player can use some resources within the gang to punish the second for defection or whatever. And then for the second player, the payoff is -4. And the same if it's the second who joins and the first who doesn't. So it's a -4 for the first and -1 for the second. And if they both join gangs, then they can use those resources against each other. That's like the nuclear option, and get -3 both of them, right? So in a game like that, this is what the players could do. That's how the story goes. The first and the second player in the first stage here, why they still have some choice about what they could do. First stage. They just tell each other, okay, here is my offer. If you cooperate, the first player says to the second, if you cooperate, then I will cooperate too. And in the second stage, this is the second stage, and in the second stage, I will not join again. I will not join again. Right? However, but if you defect, then in the second stage, I will join again. Right? So the first is saying, here is your choice. The first says to the second, I will cooperate now. Please cooperate too. And if you do, then I will not join again later. However, if after the first stage, after trying to cooperate with you, I see that you defect on me, then in the second stage I will join again. So the second has to compare the payoffs, right? Second player thinks, okay, if I defect now, then my payoffs will be as follows. In the first stage, I will get +3, right? Because I defect against a person who cooperates. So then I get 3. And then in the second stage, the first knows that I have defected. Oops. The first knows that I have defected because after the first stage, the first player sees that she's got -1, so she, puts 2 and 2 together and she thinks, okay, I've been defected on. And according to this strategy, to this promise or threat that she made, she will join the gang. So in this situation, in the second stage, I'm basically choosing between two payoffs. It's either -4 if I not join the gang then, or -3 if I join the gang. And of course, my best response to joining the gang by the first player there is also to join the gang. So it's 3 and then -3, it's a 0. By the way, maybe let's just look at this second stage and solve it very quickly so that we know what are the best responses for the players. So if the other player is not joining the gang, then it's better not to join one. Right? 0 is greater than -1. If the other player joins, then it's better to join because -3 is greater than -4. And the same works for both players. So there are two equilibria there. Right? And importantly, joining the gang by the other player makes you to join the game because that's your best response to that. So returning to what the second player thinks. Second player thinks, okay, however, if I cooperate, then in the first round my payoff will only be 2, right? Because I cooperate against the cooperator. We play out this particular strategy profile. So I get 2. And then in the second stage, knowing that I cooperated in the first, the second player, as she promised, decides not to join again, right? That's how she described it here. This is her strategy. So she does not join again, and then my best response is not to join either. So it's 2 plus 0. So it gives the payoff of 2. So for the second player, it appears that then second decides to cooperate, right? Because 2 is greater than 0. However, if we look at the first stage, then, well, I mean, we solved it many times already, but you see that cooperating there is never the best response. For the second player, it's always better to defect, and so it is for the first. So effectively what that means is that if there is something that the first player can threaten the second with later on, or something that the first player can promise to give to the second or to withhold from her, then it's possible to construct a conditional strategy. Conditional strategy, that is a strategy which conditions some behavior of the players in the current round on their future behavior in the next rounds, when it would be already known to everyone who did what, even in a simultaneous move game, and they would be able to punish or to reward other players for doing what they asked them to do, right? So if you construct a conditional strategy, then you can make players cooperate. And of course, with the repeated game, the idea is that given the fact that the same interaction repeats itself, players are supposed to construct such strategies. So we should expect them to communicate with each other and to show which rewards and which punishments they will give one another for behaving or misbehaving, right? Except here with the prisoner's dilemma, the problem is that if we returned to the formulation which we had above, this one, where the prisoner's dilemma repeated itself, right? Where the second stage game was not about joining or not joining the gang, but rather about, again, cooperating or defecting. There was nothing that they could reward each other with, right? There was nothing they could promise, nothing. There was no promise that they could commit to credibly, because it would be just impossible to believe a player saying, okay, if you cooperate with me now, I will cooperate with you in the next round, right? Because they should never cooperate in the next round. It's just a dominated strategy. They would never do that. We'll discuss a trick which allows us to make them cooperate in the future rounds, even where it is only the prisoner's dilemma which repeats without any, different games added to it.